In this video, I'm going to show you how to make a scatter plot, and in addition to the instructions that are here in this video, I'm also going to show you how to do some linear regression analysis and draw the trend line and how to interpret some of the numbers that the calculator will give back to you. So the first thing that I want to show you how to do is to turn the diagnostics on for the statistics functions that I'm about to do. So sometimes that's in your mode. If you come down here, if you have a newer calculator, it's right here that says stat diagnostics. I want that to be on. My stat wizards are on, that's good as well. For people with older calculators, it's not in that menu. You only have this first menu and you don't have anything below that. So you're actually going to have to go into your catalog and look under D. The alpha is already here, so you're going to have to look under D for diagnostics and look for the command diagnostic on, and it's going to say done, and that's how you turn your stat diagnostics on. I'll explain when we get to a certain point in the process what that did. But for now, we're going to clear our list, second memory. I'm going to clear all my lists before I get started. And I'm also going to make sure that I turn all my plots off. So in it's just stat plot, make sure that all my plots are off. Number 4, there we go. And edit. I'm going to put this data in here. I'm not going to pay attention to the name of the company. I'm interested in my independent variable being total sales, which is this column, and my dependent variable being profits, which is this column. So I'm going to put my independent variable in L1, 9.5, 22.0, 35.0, 64.0, 27.5, 45.0, 15.0, and 57.0. And next column, 0.5, 1.4, 1.8, 3.0, 0.9, 2.6, 0.8, and 2.2. I'm going to second quit and go out to my stat plot, turn my plot on. I want a scatter plot like so. I want my X list to come from L1, my Y list to come from L2. And that's okay for my marker for my order pair. I'm going to make sure that there's no Y equals equations in there already. There's not. Then I'm going to hit zoom 9, and that's going to show me my data here. And I can look at the window and I can see that it was, so if I want to make this window right here so that it matches my graph, I want to go from 0 to 80, and I want my tick marks to be by tens. And then I want my Y to go from 0 to 4, and my tick marks to go by 0.5s. So now let's look at that graph, and it's going to look like that. I can trace and see every single one of those data points from the list, where they're at, and get their exact coordinates to make my graph. but I'm more interested now in the trend line, even though that's not part of my instructions. So I'm going to second quit, stat, calculate, and I want linear regression AX plus B. My X is coming from L1, my Y from L2. I do not have a frequency list. If you have the option to store your regression equation, that's great. I'll show you how to do that. If not, I'll show you how to pull it up from an older calculator. So right now I'm going to go to vars, yvars, function, and y1. That's why I cleared out all the previous lines. I'm going to calculate. There's my slope. There's my y-intercept. And this r squared and r were the things that were not there. Unless I turned my stat diagnostics on, it would have only given me a and b, and it would not have given me r squared or r. So r squared tells me that 87% of my change in y can be explained by my change in x. So 87%, 87.1% of my change in profits can be explained by my change in total sales. And 12.9% has to be attributed to other factors other than total sales. So it's a good indicator of what's going to happen to profits, but it's not the only indicator of what happens to profits. Another way to look at that is that if we take the square root of r squared, we'll get this number r, and it's positive. And that's quite a strong positive correlation, because your correlation coefficient here goes between -1 and 1, with -1 being a perfect negative correlation and 1 being a perfect positive correlation and 0 being no correlation. So when we're in the 90% range or above, we have quite a good model here that we would use to be able to make a function to predict what's going to happen. And we would have some error in our forecast or in our model, but it's the best model that we can make with the data that we have. So I'm going to go ahead and show you that line of best fit there with that data. See how in relation to the last video that I did, this would indicate a strong positive correlation. Now, in my regression analysis, it gave me the option to store the equation in y1. Let's say I have an older calculator that didn't have that option. How am I going to put my regression equation that got calculated into y1? I'm going to go into vars. Then I'm going to go down to number 5 to statistics. I'm going to arrow over to EQ, which is equation, and the regression equation gets stored as a variable. And there it is. And there's that same regression equation graphed that way. All right, I'm not going to go through all those steps again for my second example here, but I do have another example. So I'm going to quit. I'm going to clear my y equals. I'm going to turn my plots off. I'm going to clear my lists. Number 4. And we've turned our stat diagnostics on. We don't need to ever do that again. Once it's on until we turn it off. So we're going to come in now, and I'm going to map per capita GDP as the x-axis and life expectancy as the y-axis. So watch out, because they switched the columns here, but they want L1 to be the GDP, and they want to make a conclusion that as GDP goes up and the country is wealthier, for instance, that the life expectancy increases, I think, is the trend that they would like to show here. And they have a bunch of different countries here, some of them which are quite poor, like Afghanistan, that only has each person roughly making $200 of gross domestic product. Their gross domestic product, if they would split it up over all the people, each person would only get $200 out of everything that their country produces. So, and they have quite a low life expectancy compared to the other countries, that their average life expectancy is 45. Now, I know and you know that there are other contributing factors, but how much money you have does play an impact in things like the amount of medicine and healthcare that you have, and the amount of famine that is there, and other things like that. Access to hygiene facilities, like everybody having running water and all those types of things. So while this is not the only indicator, I would expect that this indicator would cause a significant, would explain a lot of the change in life expectancy. So let's see what our R and R squared values are here. And let's put our regression equation there as well and calculate. Okay, so our slope is not very steep there. That's okay. Our y-intercept is given there, and our r squared is much lower than I expected. So it's about 60% of the change in life expectancy can be explained by the per capita GDP in dollars, and that leaves about 40% unexplained. And this is some positive correlation, but I'm not sure that I would want to base a model off of this with only a 0.77 uh, uh, R value, correlation coefficient. If I zoom in on my data in just a second, there's stat plot on, there it is, zoom 9. And, ooh, yeah, look at that. See, that doesn't look linear at all. Now, it might be non-linear. There might be other models that better explain that. That looks maybe like it's logarithmic, right? So you may not be running any other type of regression analysis, but I look at the shape of that graph, and I've had pre-calculus, and I know what a log function looks like. So let me just show you that there's other types of regression that you can do here besides linear regression. There's quadratic regression, cubic regression, and so on. And I'm going to do an LN regression here because it looks logarithmic to me. That's exponential, and that's just power regression. So each of those is something that you might try and see what it looks like with some different data. So again, vars, y vars, function, y1. And ooh, look at that. All right, now that's much better. Now with this model that I have that is logarithmic, 94.5% of my change in life expectancy is explained by per capita GDP. And it's got a very strong correlation coefficient there. And if I look at the graph now, that is not quite perfect, but you don't get much better than that. So um, this is not a linear model, and not everything in statistics will be linear. And that's why the linear model had such bad regression uh, correlation coefficients, because the model was not linear, it was logarithmic in nature. So that is that example. I wanted to show you one that was nonlinear. Let's go ahead and do this one last example here, which has to do with unemployment rates and median rent for apartments. And the unemployment rate is going to be my X, and the median rent for apartments is going to be my Y. And I suppose, I'm not certain, but I suppose that these don't have anything to do with one another, that we're going to find that there's not really any correlation here. So let's go ahead and look at the unemployment rate: 2.1%, 4.6%, 6.4%, 7.1, 3.2, 7.2, 5.0, 2.4, and 3.8. And then the apartment rent in dollars: 950, 760, 1100, 650, 1070, 620, 840, 1050, and 650. Going to second stat plot, plots on. Before I even decide to run a regression analysis on this, I'm going to zoom 9 and look at how that data is all over the place. There is no way that even if I made a prediction model that it would do me any good in predicting anything. And I'm going to make it anyways just to show you how bad the numbers are here. So I'm going to assume a linear relationship there. And I'm going to say stat calc 4, enter, enter. I'm not even going to bother coming up with the regression equation this time around because I know it's not going to be useful. And so there's my slope and my y-intercept. But look at that, only 24.5% of my change in median rent for apartments can be explained by my unemployment rate, and 75.5% of the change in median rate rent for apartments has to be explained by other variables. There's a very weak, in my opinion, but very weak negative correlation here. And so even though you might say, well, negative 0.5, I mean, that seems like it's well on its way to being -1. It's almost halfway there, right? Well, remember, correlation does not always mean causation. And so even if we could find some correlation between these two things, it might be because there's other related factors that are really the causal element that have to do with, if a bunch of people are unemployed, then they're less likely to have the to fix their properties. And if the properties are in disrepair, then you're going to have to drop the rent for the apartment because people aren't going to be willing to pay as much to live in an area where the properties are not kept up. Even if it's not that property in particular that's not being kept up, if other properties around it aren't being kept up, then the median rent for the apartment should go down. So there's some correlation that's there, but it's not really a causality thing where the change in the unemployment rate caused a change in the median rent for the apartments. So that's all that I have to say about these linear regression models and scatter plot diagrams. So hope you have uh, learned a lot from this, and I'll see you for the next video.